Chapter 5 Notes, Part 3, which is going to be discussing the axial skeleton. So I need to share my screen. That. Here we go. All right. So the axial skeleton. We know the skeleton has 206 bones. It's broken into axial and appendicular. The axial skeleton is the head, vertebrae, and the thoracic cage, plus the sternum. And we're going to look at the bones involved with that. All right, so the axial skeleton is subdivided into 3 parts: the skull, the vertebral column, and the rib or thoracic cage. Okay, so let me get a little pointer so you can see. So here's the skull. Here's the rib cage, and then the vertebrae are going to be posterior to that. And the sternum is going to be included in this as well. So the skull has 2 subdivisions. We're going to start with that. We have cranial bones, bones of the head, and then we have facial bones, bones here. And let me go grab a skull. Hold on. Okay, not everybody can just go grab a skull. All right. So here we have the cranial bones are here, and then the facial bones. Okay. It's kind of interesting. Our heads are very large when we're born. And I know I've mentioned this in class. If we think about a baby's head is like 1/3 the size of its body. They're kind of like head, mid piece, butt and legs. But we as adults are not like that, right? It's probably about 1/8 of our body or so. But because of our large brains and our large skulls, that's why it actually takes humans so long to develop. All right. And that's why we are not just born and then, pushed off to go take care of ourselves. So the cranial bones are there to enclose and protect the brain. We've got 8 large flat bones. 6 of them are going to be single, and 2 of them are going to be paired, the temporal and the parietal. So our singular bones are going to be, we have the frontal bone, which is up here. We have the occipital bone, which is in the back, and part of the occipital bone, sorry, this is like, I got to do things backwards for the camera here. The occipital bone is back here. It has this thing called the foramen magnum in it, which literally means large hole or big hole. And the spinal cord is going to come out of here. So again, frontal, occipital. This is the paired parietal, the paired temporal on either side. And then on the inside here, we have the sphenoid bone. And the sphenoid bone, to me, is kind of like a butterfly, and it spans the width of the cranium going kind of from ear to ear. So the next slide. So cranial bones, what we're considering cranial bones, again, frontal, paired parietal on either side, paired temporal down here, the occipital singular bone here, the sphenoid going through the skull here. We're also going to look at the ethmoid, which is up here. And then kind of inferior to that is the lacrimal, but that's not on here. And they're also saying that the middle nasal concha, which would be here, is going to be part of the cranial bones. Facial bones, all right, what is their job? To provide attachment points for our facial muscles or skeletal muscles of our face and to kind of hold our eyes in place. And so we have 14 facial bones. 12 of them are paired. 2 are singular. The singular ones are the mandible, which is the jaw, and the vomer, which is here in the nose. Here in the nose and there. There we go, right there. Okay, let's look at that. Put my head down here. So let's go back over some bones. So here's our frontal. The parietal is here in pink, and there's one on either side. The temporal is the orangish color, and we have two temporals here. The sphenoid is the one that goes behind. It's this pink one back here that to me is kind of like a butterfly, and it goes through the skull from ear to ear. Here in orange, we have the ethmoid, and then inferior and medial to that in the green, we have the lacrimal. I think about lacrimal sounds like the criminal, and if you were robbed, the lacrimal would be the last thing a tear would touch before it left your eye. Over the middle of the nose here, you have the nasal bone. That is actually going to cover where the nasal bones are. That's going to cover the superior nasal concha. So that's why we're not labeling it in our stuff. Okay. Here you have the zygomatic bone, which is part of your lateral kind of eye socket, and you have one on either side. Here is the maxilla. Right, so that's going to be here, fused together. Here you have the mandible. In the nose, you can see this orangish color. Those are the middle nasal concha. It's actually an inferior part of the ethmoid bone, but I want you to call it middle nasal concha. And then in the green right here on either side, you're going to call that inferior nasal concha. And we have these concha in here in our nose. You might be able to see it inside the person's face right here, because what they do is they actually increase the surface area so that your nose kind of goes in waves. And so when air comes in your nose, you actually want it to move around really quickly and to actually bounce up against your nasal wall or your nasal mucosa, because it's going to clean it, it's going to humidify it, and it's going to warm it. And so that's why we have those nasal concha there. This blue right here, this is the vomer. Right there. Here's your vomer. Okay. And then the only one you can't see in this picture really is the occipital, which is in the back of your skull, right here. Okay. So here are facial bones, maxillae, zygomatic. So maxillae, zygomatic, lacrimal, nasal, vomer, inferior nasal concha, middle nasal concha is going to be above that, mandible, and then you have the hyoid, and that was that, kind of Jeopardy question I talked about, was a bone that doesn't articulate with any other bone. We did mention this at the beginning of this chapter, the fetal skull. So a baby skull, all right, so you see how these cranial bones are totally fused together. So we call these types of joints synarthritic joints, which means they're not movable at all. They are fibrous joints, also meaning that there's not a lot of give to them. A baby skull, so where we have these joints in the skull here, are not actually completely ossified or turned into bone yet. And what that does is that allows for the fetal skull to compress during delivery. And you might have seen a baby. Babies have soft spots in their skull. And where those soft spots are where pieces of the skull, the bones are meeting, and they're still cartilaginous. They haven't completely ossified or turned to bone yet. It allows the brain to grow. It allows the skull to compress during delivery, and it can take up to about 2 years for those fontanelles, which we call those soft spots, to completely ossify. So here's a fetal skull. So these would be the cartilaginous points that have not completed ossification. All right, so that was the skull, so cranial bones and facial bones. Now we're going to talk about the vertebrae. So you have 26 irregular bones in the adult skeleton, okay? The adult skeleton has that S-shaped spine, and we talked about at the beginning of the chapter, so babies are born with a primary curvature, which has a C shape to their spine, but as they get up, crawl, and start to eventually stand, they are going to go to the secondary curvature look, which is the S curvature. So the head has to be up, the shoulders have to be back, and that makes the lumbar vertebrae kind of tuck in. All right, there are 26 irregular bones, okay? So 26 irregular bones here. So 7 plus 12 plus 5 gives you 24. So going from, so this is superior to inferior here. We have cervical vertebrae, thoracic vertebrae, and lumbar vertebrae. Inferior to that, we have the sacrum, which is bone, and then we have the coccyx, which is considered one bone. And so we have the sacrum, I'm just going to say that is considered one, and the coccyx, which is considered one. And so if we add these numbers together, 7, 12, 5, and then 2, that comes to 26. Again, in the adult skeleton, there's more in the fetal skeleton because the sacrum and the coccyx are not fused together. Okay. Go back to a laser pointer. Okay, so we have 7 cervical vertebrae. You eat breakfast at 7. You have 12 thoracic vertebrae. Those are the ones that are all going to articulate with ribs. Okay, you have breakfast at 12. You have 5 lumbar vertebrae. Those are the part of your back that's kind of tucked in. They are the weight bearing, and you eat dinner at 5. Collectively, the sacrum and the coccyx, they're 1 and 1, but there are 9 bones spread out in between them. And remember that you have a snack at 9. So 7 breakfast, 12 lunch, 5 dinner. Well, if you have dinner at 5, you're probably going to be hungry for a snack at 9. So these individual vertebrae are going to be separated by cartilaginous discs. We call the joints in between our vertebrae amphiarthritic, amphi like amphibian, and it means like slightly movable. Okay. So as I said, here we have 7 cervical vertebrae. So when you hear C1, C2, C3, that means C cervical. We have 12 thoracic vertebrae, 5 lumbar vertebrae, 1 sacrum, and 1 coccyx. Breakfast at 7, lunch at 12, dinner at 5, snack at 9. 26 total vertebrae. I've already talked about this. We are born with the primary curvature of our spine, which is a C shape. As we start to stand up and move, we're going to develop that secondary curvature, which makes our spine have an S. Looking at individual vertebrae and their anatomy, I am going to ask you to know this. Find a vertebrae here. So this would be a lumbar vertebrae here. It has a huge vertebral body. Okay. So looking at its parts. So this is a I'll start here. So this is the vertebral process or spinous process. Sorry. Spinous process is the part that's going to stick out of your back here. On the sides here, you have transverse process that are going to the side. This is the vertebral body. This is the vertebral foramen, the hole that the spinal cord is going to go through. This is the lamina here, and then we have the pedicle down here. So if I hold this like this, okay, try to get this up here. Nope, I would not be a good laparoscopic surgeon because I can't move. So here is your, here we go. This is your, here we go. Spinous process, transverse process on either side, vertebral body, vertebral foramen is the whole, lamina, kind of this section up here, pedicle is here. And I talked to you about a procedure where they actually have to get a needle to go through the pedicle into the vertebral body so that they could fix any fractures. That's called a vertebroplasty. If they're trying to repair the height of this, that would be called a kyphoplasty. Right, those are our vertebrae. And then lastly, we have our thoracic cage, which is going to consist of the sternum. So the sternum, the ribs, and our thoracic vertebrae. Okay, so our sternum. It looks like a bug upside down here. Okay, the sternum. It's flat bone and it has 3 pieces. I'm not sure if I put this in, you can see. Okay, but it has, this is the anterior side. It has the manubrium, the body, and the xiphoid process. This little piece down here. And you may have heard about people doing CPR correctly. If you don't put your hands correctly in CPR and you go too far down, you can actually break off this xiphoid process. And that could, puncture somebody's heart or their lungs, something like that, and that could be bad, okay? But again, the sternum, 3 bones put together, the manubrium, the body, the xiphoid process. So just as I'm showing here, the manubrium, the body, the xiphoid process. Okay. When it comes to ribs, we have 12 pairs of ribs, and then so 12 pairs means 12 times 2 is 24 ribs. Pairs 1 through 7, so 1, 2, 3, 4, 5, 6, 7. All right, I'm not showing the actual rib here, but they are called true ribs because they directly connect to the sternum via their own cartilage. Okay, pairs 8, fine, 8, 9, and 10. Okay, we call these false ribs because they do not have their own cartilage, but they connect to the sternum via the cartilage of the seventh rib. And then finally, floating ribs, which are not even shown on here, essentially, is because they have no cartilage that's going to connect to the sternum whatsoever. And so if you think about true ribs are going to be pretty well reinforced because they directly attach to the sternum. The floating ribs, again, connect to the sternum via the cartilage of the seventh rib. This would be right here. And then floating ribs are not going to be connected to the sternum at all. So here we have pairs 1, 2, 3, 4, 5, 6, 7. As you can see, they all have their own cartilage that is going to directly articulate or connect with the sternum. Pairs 8, 9, and 10, they connect via the cartilage of the seventh rib to the sternum. And then the floating ribs, pairs 11 and 12 down here, they do not connect to the sternum at all. That is it for Axial skeleton.